Have you ever thought about how to run a large language model on a small machine like a laptop or a Raspberry Pi? I'm talking about AI that doesn't cost a subscription, AI with no usage limits, and you also get full control over your data. All right, my friend, stay tuned since I'm eager to show you a project named Llama.C+, and show you how to use your own local AI models for total privacy and full data control. And get all of this. Let's dive in. So if you think about most large language models, well, they're built to run in massive data centers that are both costly and power hungry. So let's go over this. Imagine we're making a request to our model and we're going to say something like, hey, based on these documents, I want you to answer this specific question. And we'll add in our document sources here that might be PDFs. They could involve different types of spreadsheets and file formats using a method called Retrieval Augmented Generation, or RAG, which moves our original question over and loads some context from those documents into the model's context window. So this is the context right here. And it might not just be documents, right? It could be data sources such as a database or something. So we can link up those different data sources using a standard known as Model Context Protocol. So this is going to send out to our different CRMs and sources so you can get that info into the context window, just like we do with Retrieval Augmented Generation. So now we're taking all this info and putting it into a single prompt. We'll send that over to our large language model. So this is him over here, and this is our LLM that's running. But the point is, if we're using RAG or just asking questions or vibe coding, using Model Context Protocol to maybe get some agentic functionality. So our agent is right here, reasoning back to and fro with the data, no matter what we're using at the end of the day. Or plug it into the prompt to get our response back. It always ends up going to an LLM endpoint. So generally, lots of developers end up starting out with some kind of proprietary model. It might be an API, and it's super easy to send that request to a server, like I said before, that's running in the cloud. The catch is that it can rack up costs super quickly since you're billed based on the number of tokens you use. And the more info you're putting in your prompt as it gets bigger, the more it's going to cost you and your organization. And at the same time, well, if you have secure and private data that's being sent, well, it's also a concern for governance and compliance there. So what's going on now? And due to this situation, well, many developers are starting to look into running their own, run large language models on your own device since you don't need to worry about cost because you already have the hardware or the data leaving your premises. And that's the concept behind Llama.C+, which is to run these locally. Run large language models on your own hardware without having to send stuff to the cloud here, since we already own our own machine that can run these models locally. And so what we can do is take this whole AI application we already have set up, and we can begin sending those requests to a local model. If you've ever heard of Llama or DANT or GPT, for all of these tools are using Llama.C+ under the hood to run those LLMs. But how does that actually go down? Well, we're going to chat about a couple of optimizations that Llama.C+ uses to run them on small amounts of hardware. So how does Llama.C+ work? All right, let's start with the model itself. So picture some open models you've come across, like DeepSeek, for instance. Or maybe you've heard of the Llama family of models, or maybe Quen perhaps, and many. Most of them come from a single spot, like Bugging Face, or other repositories with open source models you can use right now. What Llama.C+ does is it uses a specific format called gguf. So it takes the model weights here, we have the weights, and it also gathers all the metadata in one spot and saves it as this GUF file, so ggf, and this makes it really simple to quickly load and swap models. So suppose I'm kicking off with DeepSeek, but I need Quen, for example, to handle some retrieval feverbutt. We can use augmented generation for tax tasks, or perhaps the Llama family of models to do something, which lets me easily swap and change, because this is all bundled into one format now. When models drop, they usually come out in a format or precision called 32-bit or 16-bit. So imagine this is 16-bit, and we have high accuracy for this model. But the thing is, right at the same time, this needs a ton of RAM to store it and execute this model. So the idea behind Llama C++ and these giga formats is that you can shrink the model down to a lower precision. So instead of 16 bits, we're going to store this as 4 bits. So we still have pretty similar capabilities and maybe still keep a high degree of accuracy. But instead of needing that huge amount of RAM, we only need it here. Allocate only 25% of the hardware capabilities to run this model. The cool part is that we need less hardware and can run these models on smaller machines. This is called model quantization, and it's the process of going from high precision to low precision when we store the weights. So, for instance, you could see scenarios with these open models where they come out as something like DeepSeek, and they follow this naming pattern too. So it would look something like quantize Q for quantize, and then at 4-bit precision. And then we're also going to check out a specific compression algorithm. And type, so we're going to do underscore K and M. And I won't get too into the depths here, but this is just the quality tuned variant you usually find when browsing open source models online. And that points to the model compression applied to cut hardware usage by maybe 75%. And the capabilities required to execute the model while also delivering much higher throughput when you're actually running this for various jobs. When we get to speed, let's chat a bit about how Llama C++ has optimized kernels for almost every platform. So maybe you're on a Mac, which means Metal support is available, or you've got an NVIDIA GPU. So accessibility for CUDA, maybe you have an EMD card, so there's Rock M here, also Vulkan. And here's the thing, whatever you run, you get support for all types of models on all types of hardware. Of course, it includes the CPU too. So the cool part is you can swap in different models and compress them and make use of them in an optimized way. So what does this actually look like in practice? Well, as an engineer, as a developer, if you're just fiddling, you can give Llama C+ a shot and use it via the terminal with the Llama CLI. So the Llama CLI lets you call up a specific model, and this will be model.guafa, and run that and chat with that using your own terminal or CLI Truntas. But for many use cases, you're going to want a local server that's compatible with OpenAI. So to do this, we'd run the command llama server pointing to the model, and we'd type in the model here, but we'd also do a port assignment. So port 80, and on that port, we'd be able to send a GET and POST requests to connect different extensions. Maybe you're using something like LaneChain or LaneGraph. Well, you still get the same compatibility with remote servers, but also local model servers you might be running too. Plus, there are extra features with Llama C++ specifically. For features like handling images and describing what's going on in them, or as I said earlier, the link between the various services your AI models might want to use with the Model Context Protocol that lets you pull in databases from your CRM or whatever you call it. So thanks to the open source community, AI is getting more accessible than ever, from models to compression to kernels, and support for devs who want to run their own local AI models knowing their data stays on their device. And there are no rate limits or API outages. Really appreciate you watching. If you picked up something new today, make sure to drop a like and hack the algorithm as well. Stay subscribed for more content on AI and open source technology. Thanks and have a wonderful day.